People, I am pumped right now. Oh my gosh, my hair is all a mess right now. Oh jeez. I am pumped right now. It is Saturday night. It's 11 o'clock Saturday night. I've got ESPN's got a replay of the national championship game this year, the Clemson LSU championship game. It got that playing on the background. Kids are asleep. Oh man, I'm excited right now. And you know what? The main reason I'm excited is because I get to teach you the unit circle. Like, what other thing would I love to be doing on a Saturday night? Teaching the unit circle? What? I am hyped. Like, I know I say, like, oh, this is one of my favorite lessons. Like, you've heard me say that all year. Like, oh, I love teaching this lesson. This is great. That's how I sound in my head. But this lesson, this one, like section 13.3, that may be my favorite lesson of the year. This may be my favorite lesson of the year. We get to spend a whole week on this lesson. I know it's spread out because this whole pandemic thing, but we get to spend a whole week focusing on the unit circle. Nothing sounds better. Nothing sounds better. You know what? I'm a happy guy. Okay. So what I'm basically, if I were to teach this in a regular setting, I would be teaching you this first part of the lesson in one day. Okay, in one day. I know this lesson, like like if it's a 48-minute class period, it goes bell to bell. This lesson may be a little bit. I'm really anxious. I should stop stalling because I'm a little worried about the length of this lesson because it might be a little longer. Because usually I start teaching at the bell and I am rushing to get the last few parts in a normal class period. So hopefully I can get it done in time whatever. But pause where you need to. There's a lot of times in this lesson, like if it was a normal class, I'd have to wait for you guys to write things down. I'm not going to be waiting. I'm just going to keep going. And so so hopefully it's not going to be too long. But today is more of like learn what it is. And then the next lesson of the week is going to be learning more why is it useful. Okay. So let's just jump right in. Right. I'm gonna get myself off the screen. I'm already embarrassing myself enough. Okay. All right. Section 13.3, the unit circle. So this is what we're going to be learning today. Okay. You will have to memorize this. Well, that's, I say that and I'm going back on my word already. If this was a normal class, I would make you memorize this. You are probably the only class that I'm ever going to teach this to, unless this happens again next year, which I hope not. That will not have to do a unit circle quiz. Usually I teach this lesson, giving them a day on it, and then the next day I make them recreate this whole thing from scratch in 10 minutes. Okay. Knowing that you have to memorize it. But this is what we're going to look at today. Now we're going to derive this whole thing. What does it mean to derive it? That means I'm going to show you exactly how to get each part of this from scratch, like without even needing to know. I'll show you. I'm getting ahead of myself. Okay. What is the unit circle? The unit circle is really just a memorization tool. Okay. It's a memorization tool. It tells you a lot. Like, think back in elementary school, you had your times tables, right? And like you just had to memorize that 8 times 9 was 72 and 6 times 7 was 42, and you just had to memorize those things. Could you go to a calculator and actually figure it out? Of course you could, but why waste the time in going to your calculator that you could be just advancing through, right? Like perfect squares, you memorize perfect squares because they're numbers that come up very often. Like 8 squared is 64. Hopefully like 12 squared is 144, or 15 squared is 225. And the reason being, those so that things move a little quicker and you don't have to rely on a calculator as much, right? That's the same idea of a unit circle. Could you go back and find these things within a calculator, within some stuff? Of course you could, but you don't need to. We're smarter than that. Okay. All right. So that's basically the unit circle in a nutshell. It's a memorization tool. All right. Now there are some things on here that look a little weird. Like, what the heck is this? Like, where are all these pies coming from? What is all that stuff? Okay, so in your math life, you've only learned angles that have been expressed as degree measures. Okay, today you are going to learn another way to represent angles, I guess, if you will. Look at that. I'm like almost reading it word for word. Oh, man, I love this lesson. So far, you've measured angles in degrees. Like, that's all you've done, right? You can picture what 30 degrees is in your head. You could picture what 90 degrees is in your head. You could picture what 180 degrees is in your head. But can you picture pi over 2? Can you picture pi over 4? Can you picture pi over 6? No, because you don't know what that is yet. Those are all radian measures, okay? Those are all radian measures. A radian measure is just a way to represent an angle given that's based on a radius. Okay, that's where they get the word from, right? Radius, but that's you. Okay, radius, right? That's the root word of radian. A radian is a unit of angle measure based on arc length. Okay, it's all based on arc length. Apparently, I got off the screen a little bit there. It's all based on arc length. Okay, distance around a circle. Now, think back to geometry. An arc is an unbroken part of a circle going along the outside. If a central angle theta in a circle of radius r intercepts an arc of length r, then the measure of theta is defined as 1 radian. Okay, what does that mean? What am I saying there? And don't worry about this thing here in a second. I'll tell you to write that down here in a second. If I draw a circle, okay, wow, that is awful. If I draw a circle, much better. And then I take a radius out of that circle. Okay, so take this length here. If I take that radius length, call it r, okay, and I wrap it around a circle. Say I'm taking this exact length and I wrap it around a circle. Say I start here and I wrap it around the circle. Okay, say it ends there. I don't even know. I should really get a string and measure that. And I'm going along the arc. It almost looks like I made a chord there. Whoa. It almost looks like I made a chord there, but I am going along the curve of the arc. The angle, the central angle, so angle formed at the center, we'll call this theta for right now. The angle formed that intercepts that arc, okay? That angle formed that intercepts that arc, that is called 1 radian, right? That angle is 1 radian. So it's all based off the radius length, okay? All based off the radius length. So think about this. How many radians are in a full circle? How many radians are in a full circle? Well, think about, this is all about arc length, right? What's the full arc length around a circle? What's another way to call that? Circumference, right? Isn't that the distance around? So circumference is equal to 2 pi r. 2 pi radians. That's a full distance around a circle. 2 pi, okay? Yeah, 2 times 3.14. There are actually roughly 6.28 radians around that make 1 full rotation. Okay, so how do we convert? How do we convert from angle measures from degrees to radians and back again? Well, think about what is the equivalency. So if I say 2 pi is my radian measure for 1 full distance around, 1 full theta that goes all the way around the circle, what is that in degrees? Well, that's equivalent to 360 degrees, right? Well, okay, so I should have put 2 pi radians here. Well, think about this then, okay? So divide by 2, pi radians is equal to 180. So radians is equal to 180 divided by pi. And that's where I get this thing, okay? 180 divided by pi. That's the conversion factor. And if you wanted to go back again, look, I took the reciprocal of that, right? If I wanted to go from degrees into radians, well, then I would be taking pi divided by 180. Okay, I would just be reversing this, right? All right, it bothered me that I didn't have the 2 on both sides. So that's really, you know, in a nutshell, how to go from one degree measure to 1 radian measure, and 1 radian measure to 1 degree measure. You either multiply by pi over 180 or 180 over pi. Here's the thing to think about. Radian measures always include pi. They take pi into account because it's going around the outside of the circle. Now, if I want to put pi in, meaning going from degrees into radians, I want to put pi in, I'm going to put pi in the numerator. I'm going to put it into the value. If I want to take pi out, going from radians to degrees, I want to divide it out of the way. I want to get it out. So that would mean I want to divide it. I want to put it in the denominator of the fraction. That's how I memorize, or how I think about transferring from one to the next. All right, convert each radian measure, or sorry, each degree to radian, or radian to degree. So this is already in degrees, so I'm going to take negative 60, and I'm going to, I don't know why I wrote a fraction there, sorry about that, negative 60, and I'm going to multiply it by pi divided by 180. Okay, now, I'm not actually going to multiply by 3.14. I'm going to take negative 60 pi divided by 180, and I'm going to reduce this fraction. 60 over 180 is 1/3. So it's negative pi over 3, right? So here's how I would do that. Let me get that out of the way. You would take 60 divided, I'm just going to punch this in, 180, and then I would take that answer and put it into a fraction. 1/3, pi over 3. And it was a negative, so it's still a negative. So negative pi over 3. Okay, so picture negative 60 degrees, right? Picture negative 60 degrees. Negative rotation down in 60 degrees, right? So this is negative 60 degrees. That is also equal to pi over 3. Negative direction, but pi over 3. Okay. All right, let's try another one. Okay, so it's in radians. We'll go to degrees. Okay, so 2 pi over 3. I'm going to multiply by 180 divided by pi. I want to take pi out of the equation. I want to take the radian out. So I'm going to cancel out pi. That's going to be 2 times 180 all over 3. So 360 over 3, or 120 degrees. So picture 120 degrees in your head, right? You don't have to draw this out. I'm just trying to get you to think about it in a different way. So here's 120 degrees, right? That is a 120 degree angle. That is 2 pi over 3. Okay, that is 2 pi over 3 radians, which is equivalent to 120 degrees. Okay? Think about it this way. You know, you learn English. You speak in English. You learn a new language. You really are going to, when you learn the new language, you're always going to be translating back into English, thinking about it in English. You know, if somebody asks you a question in Spanish, you're probably translating it in your head, thinking, okay, what did they say in English? Think about what you want to say back to them in English, and then you spit an answer back to them in Spanish, right? So you have to put it in terms that you know. So like, that's why I'm always relating this back to degree measures. You know degree measures. So now I'm going to always try to relate it back to, okay, what does it look like in degrees, so that you can think about it in radians. Soon enough, you'll be able to visualize, okay, 2 pi over 3, that's 2 pi over 3. You're going to be able to do that pretty soon. Okay, I'd like you to pause and try these two. Okay, so we got 2 pi over 9. I'm going to multiply by 180 over pi. Okay, that's going to cancel the pi's out. I'm actually going to cross reduce a little bit here too. I'm going to take this 9 and 180. I'm going to divide 180 by 9. When I do that, I'm going to get 20. So that's going to really be, oops, let me get blue back. That's going to really be 2 times, that's going to cancel here and get 20 right here. 2 times 20 is 40 degrees. So picture 40 degrees, a little bit less than halfway. That is 2 pi over 9. Okay? All right, 280 degrees. And think about where is 280 degrees. Here's 180 and then 100 degrees more. So 270 is down here, so here's 280 degrees. That's the rotation of 280 degrees, right? Okay, so let's take 280 and put pi back into the equation here. We got, so really it's 280 pi over 180. Okay, so I'm just going to take 280 divided by 180 and turn it back into a fraction. Math, back, enter. 14 over 9. 14 pi over 9. There's my answer. Okay. All right, so you should know now how to transfer from radians to degrees and degrees to radians. Okay, just know the conversion factor of pi over 180 or 180 over pi. All right, so let's get to it. Now, I like to think about, and this is all kind of weird. I like to think about what the heck? Whoa, 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 whoa. Yeah. I like to think about the unit circle as like function families, angle families. Okay, angle families. Okay, so this is, now each point along the unit circle, again, I'm going to show you how to derive these. Each point along the unit circle is going to have four things. They're going to have an x coordinate, they're going to have a y coordinate, they're going to have a degree measure, and they're going to have a radian measure. Okay, each one should have those four things: x coordinate, y coordinate, degree measure, radian. Okay, so this is going to be, I like to call this the axis family. Axis fam. All right, so what I'm going to talk about are these four coordinates here, the ones that are on the axes, right? Let's start off with the degree measure, shall we? So this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. 0 could also be considered 360 as well. Okay. Let's put them into radians. Okay, now we know 0 is 0, but we also know 360 is 2 pi. 0 or 2 pi. Okay, now think about this. If 2 pi is a full rotation, what's half a rotation? We'll divide it by 2. Pi. Okay. And there's no label for radians. Sometimes I see like pi RAD for radians, but I don't really put anything there. Okay. If you see a pi, you assume that it's in radian measures. Okay. So here's pi radians. Let's talk about 90 degrees. Well, if I want to look at 90 degrees, if 0 to 180 is pi, so what's half of that? Pi divided by 2. Okay, so think about this. I'm going 0, 1/2 of pi, pi over 2. Whole pi, chocolate peanut butter, please. And then what's here then? 1 1/2, right? This is 1 and 1/2 more. 3 pi over 2. Okay. So there's my degrees and radians. Now, could I have just transferred those, taken 180 over pi or pi over 180 or whatever you want to do? Sorry, pi over 180. And done this conversion factor that we did before? Of course you could, but that would take too long. Okay. So that's the, oh, I forgot my coordinates because these ones are easy. The coordinates are easy. The coordinate here would be, okay, it's 1 unit out here, no units up. This is no units left or right, 1 unit up. This is -1, 0, and this is 0, -1. I think I forgot to mention that we are having this unit circle. If I talk about the unit circle, okay, the unit circle, we are assuming that the radius is equivalent to 1. Okay, we are assuming that the radius is equivalent to 1. That's where I'm getting these coordinates here. Okay. If the radius is equivalent to 1, then the radius is equidistant to all of these coordinates. So therefore, that's where you see the coordinates. Okay. This is going to be a very key component here coming up in the next family. Okay. I forgot to mention, I should probably go back and put this at the beginning of the video, but you should really be, sorry, I got too excited, I got ahead of myself. You should really be doing this all on the same unit circle. You should print out a unit circle. Maybe I'll make like a special note on the assignment. Thinking about that. Yeah, you should really have one there for you, and you should be doing it on the same one. Each family should be going on the same one, so you're building this whole thing as you go, that whole unit circle as you go. Okay, back to this. This is going to be called the 45 family. This is the 45 family. Now, there are 4 coordinates in each family. We have the axis family here. This is going to be what's called the 45 family. Okay. Now, where am I going to get these? Well, this is going to be 45 degrees. Okay. Let's think about it in terms of radian measure. Okay, let's think about it in terms of radian measure. We just figured out that this coordinate up here was pi over 2, and this was 90 degrees. So isn't 45 degrees half of that? Yes. So what is halfway between 0 and pi over 2? It would be pi over 4, right? 1/2 of pi over 2 is pi over 4. So that's my radian measure, pi over 4. I would also call this the pi over 4 family. Okay. Now, here's where it starts to get real fun. The radius, I just talked about it. The radius was 1, right? The radius is 1, okay? Now, look at what I'm going to do here. What did I just draw? I just drew a triangle, right? I just drew a triangle, but not any triangle. What's my theta? Oh, my theta, it opens up 45 degrees. What type of triangle did I just draw? I just drew a 45-45 right triangle with the hypotenuse set to be 1, because the hypotenuse is the radius. And we knew that the radius is, since it is a unit circle, the radius is 1. I told you it'd come back. Okay, now, if I'm given the hypotenuse, I can figure out what the sides are. I would have to divide by the radical 2. So I would be taking 1 divided by radical 2, right? To get from the hypotenuse to the side length, I would say 1 divided by radical 2. Okay, so that's equivalent to, when I rationalize the denominator, radical 2 over 2. So my x-coordinate is a radical 2 over 2. Coincidentally enough, or maybe not so coincidentally, the y-coordinate is the same. Okay, they're both radical 2's over 2's. Okay, radical 2 over 2's. Why? Because it is a 45-45 right triangle. Okay, now, I say it's a family, so there's got to be multiple members of the family, right? Okay, so all the members of the 45 family are each 45-degree angle in each coordinate. Now, why are they all in the same family? Why are they all in the same family? They're all in the same family because they have very similar coordinates. They have very similar coordinates, okay? How are they so similar? Well, isn't this just a reflection? It's have the same y value, and isn't this just a reflection over the y-axis? So this would be a negative distance this way, and the same horizontal value, or the same vertical value. Wouldn't this one be the negative versions of each one? Negative radical 2 over 2, negative radical 2 over 2. And wouldn't this one be a positive then a negative? Radical 2 over 2, negative radical 2 over 2. You know, think about it. I know in any coordinate plane, x and y are both positive here. X is negative, y is positive here. Here is negative, negative. X and y are both negative, and here is positive, negative, right? X value is positive, y value is negative. That's going to be the signs for each of these coordinates that go along. Okay, so let's keep going. So think about the 45 family. This is going to have the same reference angle here. Because it's a reflection over 45 degrees here is 45 degrees here. Those angles are congruent to one another. So what would be my angle measure there? 135 degrees. Okay, 135 degrees. Okay. Now, right, I'm like second guessing myself. Is that one? 80 minus 45? Whew, yeah, it's almost midnight, folks. All right, and now, again, the same reference angle down here as well. Okay, coincidentally over here too, but we'll get to that in a second. So if this is 180 plus another 45 degrees, that's 225 degrees. Oh, I can't write in blue. Are you serious? Okay, 225. Here you can think about it as 270 plus 45, or 360 subtracted away from, or sorry, 45 subtracted away from 360. I'll think about it as 270 plus 45 because that gives me 315 degrees. Now we have to think about them as the radians. Now, could you go and transfer each one of these using the formula? Of course you could. But I like to think about it logically. This is pi over 4, and that means it's cutting the whole circle into fourths. So this is 1/4. This would be 2/4. This would be 3/4. 3 pi over 4. This would be 4/4. This would be 5/4. 5 pi over 4. This would be 6/4. This would be 7/4. 7 pi over 4. Don't believe me? Run the numbers. Multiply by pi over 180. See what happens. Okay. All right, so that's the 45 family. Let's look at the next family. Okay. Again, keep overlaying what we've learned, what we have, right? Keep building on the same unit circle that you're working with. Okay, so we've done the axis family, we've done the 45 family, and now let's do the, this is the 30. This is the 30 family. All right, and it's the 30 family, obviously, because this is a 30-degree angle, okay? That's a 30-degree angle. It's opening up to 30 degrees. In terms of radians, now this one's a little not really logical, so I'm just going to multiply. If I take 30, didn't I do this already? I feel like I did this. No, I didn't do this already. If I took 30 times pi over 180, that's going to give me 30 pi over 180, or if I cross reduce there, that's going to give me 3 pi over 18, which is pi over 6, I believe. Pi over 6 family. It's another way to talk about it. Pi over 6. Pi over 6. Okay. Now, let's talk about the coordinate. Let's talk about, why am I changing? We know the radius is 1, right? That fact did not change. Now look at what I'm going to drop down. What did I create in there? I created a right triangle, but not just any right triangle, right? I created a right triangle with the central angle of 30 degrees, which creates a special right triangle. I'm given the hypotenuse is 1. My 30 side, this distance here is 1/2. Remember, they got that 1 to 2 relationship. So this is 1/2. Okay, so what's this distance in here then? Well, this distance in here is whatever this 30 side is multiplied by radical 3. So it's radical 3 times 1/2, or radical 3 divided by 2. And that, ladies and gentlemen, is going to give me my coordinates. The x value, radical 3 over 2. And the y value is 1/2. Okay. So I've got all 4 pieces there. X value, y value, degree, radian. Now, where's the rest of the family? Now, the rest of the family, it was easier to point out in the axis in the 45 family, but now it's a little bit more difficult. The family has the same reference angle. This is congruent with this. this is congruent down here. And this is congruent down here. Sorry for the poor handwriting there. Okay, so think about it. Since it's got the same reference angle, this is 180 less 30, so 150 degrees. This is 180 plus 30, so this is 210 degrees. This is 360 minus 30, so 330 degrees. Okay, now let's talk about the radian measures. I'm turning everything into pi's over sixes. So this is 1 pi over 6. This is actually going to be 2 pi over 6. We'll talk about that in a minute. This is 3 pi over 6, right? Isn't 3 pi over 6 1/2 pi? Pi over 2. This is 4 pi over 6. This is 5 pi over 6. This is 6 pi over 6, or just pi. This is 7 pi over 6. This would be 8 pi over 6. This would be 9 pi over 6. This would be 10 pi over 6. This would be 11 pi over 6. Right? And wouldn't this be 12 pi over 6? Think about what is 12 pi over 6. 12 divided by 6 is 2 pi. 2 pi. All the whole way around. Okay, now again, think about our axes here. This is positive, positive, negative, positive. This is negative, negative, and positive, negative, right? So in this one, now again, the reason why I'm chunking these all into families is because they have the same coordinates. Radical 3 over 2, comma 1/2. But think about this chart here. It's a negative radical 3 over 2, negative x value, positive y value. This down here, they're both going to be negative. Negative radical 3 over 2, negative 1/2. This over here is going to be positive radical 3 over 2, negative 1/2. Positive x value, negative y value. Okay, so that's the 30 family. One more family to go. Let's do the 60 family. I'm trying to get these a little smaller for you, fit on one screen. Here we go. All right. Oh, let's go blue. All right, so again, this is the 60 family. This is the 60 family. So this is my 60-degree angle. Okay. What's the radian measure? Well, 60 times pi over 180. That would be 60 pi over 180, or pi over 3. Pi over 3 family. Okay, pi over 3. All right, now let's draw in that right triangle again, just like we've been doing. Here's my radius of 1. Now think about this. This is the 60-degree angle now, right? So the 30 is up here. So now this is my 1/2, right? It's across from the 30 side that's got that 1 to 2 relationship with the hypotenuse. So if this is 1, if the hypotenuse is 1, then I divide by 2 to get to the 30 side, the short side. The long side is the one where you multiply by radical 3. So this is radical 3 times 1/2, or just radical 3 over 2. So now it's actually, this almost looks very similar to the 30-degree family, but in this case, it's swapped. The x value is the 1/2, and the y value is the radical 3 over 2. Okay, so here is another member of the family. Here's another member of the family, and here's the last member of the family. Remember, they all have the same reference angle. Reference angle being the angle formed with the axis and the angle. Okay, so now this means that this is 180 minus 60, or 130 degrees. This is 180 plus 60, which is 240 degrees. This is 360 minus 60 degrees, or 300 degrees. Okay. And again, you're subtracting away the 60 degrees there. Wait a second. I was going to say, wait a second. That's wrong. I'm allowed to make one mistake each time, right? There we go. I was like, 180 minus 60. That does not sound like 130. Yikes. 180 plus. I'm just going to tell you 180 plus. All right. So now, what does that mean in terms of the coordinates, or the radians, excuse me, the radians? So I'm separating it into thirds. No thirds, 1/3, 2/3, 2 pi over 3. 3/3, 4/3, 5/3, and then this would have been 6/3 or 2 pi, right? Okay, now again, think about the chart, the negatives and positive chart. This would be this negative 1/2 radical 3 over 2. This was both negatives, so negative 1/2, negative radical 3 over 2. And this is the positive, negative. Okay, and that, my friends, is the unit circle. Okay, that is the beast. Okay, if you missed any piece, this is what you should have in the end. Whoa, apparently I had 2 pi written out there. There we go. There we go. Keep floating it around. All right, so that is the unit circle. Okay, you need every piece of this. Okay, if you memorize this, this tells you a lot, a heck of a lot of information. A lot of information. Okay, now here's why. It not only tells you what think about it. If I asked you to convert 150 degrees from degrees to radians, and you knew your unit circle, you could say that's 5 pi over 6. You don't even need to run through the calculation. You just know it, right? You don't need to go to a calculator. You don't need to multiply. You don't need to do anything. You just know it's 5 pi over 6. Okay. If I asked you to transfer 225 degrees into radians, you'd say 5 pi over 4, because you know degrees to radians. You don't need the calculation. You've got the unit circle pair. Okay. But here's the more useful part about it. And I don't want to get to that slide just quite yet. Think back here. And I'm just picking at random, this 30 family. Okay. Here is theta, right? Here's theta. Think about the sine of theta. What is the sine of this theta? The sine of this theta is the opposite. Okay, what is this? That's actually the y value, right? The sine of theta is actually the y value, 1/2 over the hypotenuse. But what is the hypotenuse? 1. That's the radius. We knew that. So sine of theta, s theta? What? Sine of theta, or actually sine of 30 degrees is 1/2. Ooh, that's interesting. So where we would need to go back, like we learned at the beginning of this chapter, that sine, cosine, and tangent are just basically placeholders for decimals, right? Placeholders for ratios. But now I can say confidently that the sine of 30 degrees is 1/2, because it's the y value divided by the hypotenuse, right? Okay, so that basically means that the y value of the coordinate that you had is the sine value. That's a surprise face. You know what else that means? Think about cosine. Think about cosine of theta. Okay, cosine of theta is the adjacent, which means it's the x value. The radical 3 over 2 divided by the hypotenuse of 1 doesn't change it. Think about any triangle that I draw in around this whole unit circle. What is the hypotenuse? Always. Hypotenuse is always 1. You're always going to be dividing by 1. So that means the cosine of 30 degrees is radical 3 over 2. Radical 3 over 2. Ooh, that is really interesting. That's the x value. Okay, here's what I'm telling you now. Here's what the book's definition. Right? Here's what I'm telling you now. That the sine of any of the angle measures is the y value of the coordinate that you wrote. The cosine of any angle measures that you have around the entire unit circle is the x value of the coordinate that you found. And the tangent, now we didn't talk about the tangent, but any triangle that I make, say I had my 30 degree cell sitting there, if I want a tangent of that theta, you'd just be taking this side, which is coincidentally the y coordinate, divided by the x-coordinate, the opposite divided by the adjacent side. So you're always going to be taking the y-coordinate divided by the x-coordinate. Okay, so quite simply, the coordinates of any point P along the unit circle can be written as cosine comma sine. You know what that means? I could say to you, what's the sine of 5 pi over 6? Ooh, okay, 5 pi over 6 is right here. Here are my coordinates. Let me move my circle a little bit. Okay, 5 pi over 6 is right there. If I asked you for the sine of 5 pi over 6, sine of 5 pi over 6, okay, the sine of 5 pi over 6 is the y-coordinate of that. So the sine of 5 pi over 6 is 1/2. Wow, that's pretty powerful. No need to go to our calculators. No need to actually punch in sine 5 pi over 6. Okay, so I ask you, what's the cosine of 315? What's the cosine of 315 degrees? Well, the cosine of 315 degrees, cosine is x value. Okay, cosine, ooh, radical 2 over 2. Interesting. Okay, here's what's gonna, here's gonna be, here, you know, this is gonna go nuts. Here, this is gonna drive it, this is gonna blow your mind, and I'm gonna end on this, and then we're gonna jump to the next lesson. What's the tangent of 270 degrees? Think about it. Think about it. Think about it. Well, it's y over x, right? Y over x. Right? We learned that from this slide. Y over x. Tangent is always y over x. Okay, so if this is y over x, that means tangent of 270, tangent of the angle of 270, 270 is down here, the y value divided by the x value. What? What? It's undefined. Yeah. Yeah. Crazy enough, it is undefined. And that's where I'll leave you with today. Oh my gosh, this is great. I'm going to just go ahead and teach the next lesson right now because I am just so jazzed about this right now. Okay, you guys have a great, what day are you watching this on? Probably Monday, Tuesday? I don't know. All right, see ya. I'm going to pick up the next lesson here in a second.